Here we have an interesting differential equation that seems impossible to solve at first because we have a mix of x's and y's and the dx and x's and y's and the dy. It'd be really hard to split this apart. But what we can do is we can label this thing right here inside the parentheses. We'll label that m a function of x and y. And on the right, we're going to label that n function of x and y. And we're going to sort of assume that there's this function over here that if we took a partial in terms of x, it would take us to this thing. And if we took a partial in terms of y, it would take us to this thing. Interestingly enough, we can actually integrate that whole mxy dx, and that will lead us straight back to f of xy. And we can do the same thing with the integral of nxy dy, and it takes us back to f of xy. So we can sort of move between these things freely. Now we're going to make a quick check. We're going to look to see, since we're integrating this over dx, let's go ahead and take the partial derivative in terms of y. And over here, since we're integrating over dy, let's take the partial derivative in terms of x. So that way we can see over here, this will simply be 1, and this one would also simply just be 1. So those two things are equal, and now we can proceed. Let's now remember this first piece of the equation. So we're going to say that the fxy is going to be equal to the integral of mxy dx. So what is that? It's just going to be this stuff. Well, let's try to do that. So the integral of 2x plus y dx is going to be x squared plus xy. And then we can set that, well, we gotta have a constant here. So we're gonna have to add a constant. Now let's realize that we integrated over dx. So we kind of left out the y's. So the constant might have y's in it. So let's put a g with as a function of y. And let's remind ourselves that this is again going to be fxy. Okay. So now let's also remember that if we take the partial derivative in terms of y, we're going to get this. So let's just write that f of y equals x plus 2y. It turns out that this, we can also take the partial derivative over here and take this f of y and figure out what that happens. We're going to take the partial over here. So this kind of goes away, and then here we were left with an x, and then here we're left with a g prime of t, or g prime of y, sorry, and that's going to be equal to fy. And it turns out that these two things are equal. But yeah, so now we figured out what g prime of y is. It's actually equal to 2y. So that's great. Now what we can do is we can integrate this over y, integrate this over y. This is just simply going to yield that g of y is equal to y squared plus some constant. Now let's look back at this equation that we had over here. It says gy right there, and we know what gy is, so let's plug that in there. So we get something like f of xy is supposed to be equal to x squared plus xy plus this stuff, y squared plus c1. There's a little bit of a problem here because we can kind of interpret this f of xy as a whole new variable. We can just call that z, right? You can kind of think of it like we got a little plane here, and we have a mountain, and well, you know, basically this is the z-axis right here, and we don't really know whether we're at the bottom, whether we're somewhere in between, and you know, these there's x and y plane over here. But the idea is that we have x squared plus xy plus y squared plus c1 is equal to the z. And the z is kind of just an arbitrary number right now. But what we can do is we can just make z constant. So if we set z equal to c, then that means that we choose one of these. So we're going to choose, I don't know, this one specifically. So now, no matter what we do, our answer must lie on this particular circle. So now we have this circle, that's a 2D circle, or potentially even just a plane right there. But yeah, so we have this 2D location, this area, instead of this 3D mountain. Okay, and that would be from x, the f of xy. That thing is 3D, but we can turn it into a 2D circle by setting a z equal to a constant. Great. Well, that means that we can say that x squared plus y squared, xy plus y squared, and then we basically have plus c1 equals c, and we can subtract c1 from both sides. All right, and so that finally gets us to the answer, which is going to be x squared plus xy plus y squared equals, well, c minus c1 is just going to be c again, or another c, so that's basically what we have right here. That constant gets absorbed, and we have our final answer. Holy smokes.